For the CircuitPython Parsec today, I wanted to show you how we can create a velocity meter on the Trellis device here using MIDI and MIDI note velocity inside of CircuitPython. So first of all, a demonstration. You can see here, I'm just going to play some notes on this little MIDI keyboard off to the side. Let me show that here. So I'm just playing some notes on here, and what you'll notice is as I press the keys lightly, we just light up a few LEDs. As I press harder, we get more of the LEDs, kind of like a VU meter, but instead of measuring volume, audio volume, it's measuring how hard I press the key, the velocity. So a lot of MIDI keyboards have this velocity sensitivity. It's fairly simple in a lot of inexpensive keyboards like this. There's just two switches that get hit, and it checks the sort of time of flight between those two to decide how quickly you've hit the key, how much velocity you've used to hit the key. So the way this works inside of CircuitPython, if we take a look at my code here, is very similar to the previous code, except this time I'm using async I/O. And this means I'm able to have two sort of main chunks of code running back and forth without getting in each other's way. It's not, strictly speaking, parallel processing, but it does allow one read of all of those MIDI notes to kind of get out of the way and let a write to all of those NeoPixels happen and do it in an organized fashion. So that gets imported. The rest of this is all the same sort of MIDI, USB MIDI and Adafruit MIDI, as well as the Neotrellis and multi-trellis. And then I have some user settings here for what velocity I want to map to what set of NeoPixels. So I have 8 NeoPixels here. Velocity can go from 0 to 127. And I am unlikely, on this keyboard at least, to press that any lighter than about a 20 or a 30. So I wanted to be able to capture that by having user adjustable velocity ranges. And then I also have some values here for how quickly those LEDs fade and how many steps of fade they have. The main functions that we're dealing with here, I have a velocity to height, and that's what says, okay, depending on how hard I hit it, how many NeoPixels are we going to light up. Drawing a column, just so we can call that when it's time. Setting up the display initially. And then here are my two async I/O tasks. I have, did I pass it? There we go. I have this MIDI task function, and I have this display task function, and those are made as async I/O functions. So in the first one, we receive a message, and from that, we check to see if it's a note on message and the velocity is greater than 0. So then we run off and say, okay, for this value that was pressed, how many of those pixels are we going to light up? We have that value stored, but we actually don't use that until the next async I/O hands off to this display task. So we've just calculated how many NeoPixels, then this is where we actually draw them. So when we flip over to this task, we check and see the current time so that we can count down for that fade. And then we run either the fade or the light up using the number of NeoPixels for that column that were determined by the previous async I/O function. And then the main loop here just runs the MIDI job, which is async create task MIDI task, and the display job, async create task display task. And then we await that async I/O gather, which says, okay, it's time to move over to the other one, and then run it. All right, and so that is how you can meter the velocity of your MIDI keys using CircuitPython running on a Trellis. And that is your CircuitPython Parsec.